The activation energy, which is abbreviated E with a subscript A, is the minimum amount of energy that is needed for a good collision to occur. The activation energy is represented on the energy diagrams for different chemical reactions. We haven't looked at energy diagrams in quite a while, but these are plots of the energy for a chemical reaction versus time. And we've looked at them in the past. We've really only looked at them in the context of whether the reaction is giving off energy or the reaction is requiring energy. So we've looked at them in the context of exothermic versus endothermic reactions. In the first graph that I drew, this was an exothermic reaction. This graph that I'm drawing is an endothermic reaction. And so far, all that we've really looked at is just comparing the relative energy of the reactants versus the products. I'm going to go ahead and label R and P for reactants and products. And we've just looked at things like the products are lower in energy than the reactants. So this is the energy that is released by the chemical reaction, negative delta H or positive delta H. The activation energy is the amount of energy that it takes to get from the reactants to the high point on these energy diagrams. So this amount of energy right here, in this case, the difference in energy between the reactants and the high point, this energy here is the activation energy. We call this, or we pronounce it E sub A, E subscript A. For this reaction, this is the activation energy right here. So as we can see, even though when we first talk about thermodynamics and we talk about exothermic versus endothermic, and we talk about how exothermic reactions are ones that release heat, all chemical reactions, even ones that are exothermic, require a little bit of energy, a little bit of heat, just in order for the reaction to take place. The high point on these graphs, where the activation energy is defined, this high point is referred to as the transition state. And the transition state gets this symbol, kind of looks a little bit like an equals sign with a vertical line through it. So this is our notation for transition state. And the transition state is the species that exists as the reactant is being reacted and the product is being formed. So in this example of a reaction that I used in the previous video, these are the reactants and these are the products. And this in the middle is the transition state. The transition state is not a reactant and it's not a product and it's not even really a molecule. It is this thing that exists in the moment that the bonds are breaking and the bonds are forming. It's very short-lived, just lives for a small fraction of a second. In this case, we can see our transition state exists as the carbon-oxygen bond is being formed and the carbon-bromine bond is being broken.